Take a look at the next example. We have function x is equal to x times exponential of 2x. This is in case 4, right? Case 4, that is the product of function 1 till 3, right? Which is the case 1, and case 2 is the product of case 1 times case 2, right? Now, to find the UC set of this function, you've got to do the derivative of the fx. The first derivative is what? X d exponential of 2x dx plus exponential of 2x dx by dx. Which is equal to what? 2x e to the exponential of 2x plus exponential of 2x. If you do the second derivative of this, you would get 2 plus which is equal to if you do further differential of this function, you would end up with the same function. So in this case, you already see what? X times exponential of 2x and exponential of 2x. Then in that case, we would be finished up at this point. And then we can conclude that the UC set of this function is equal to x times exponential of 2x and exponential of 2x. You will get two functions. Any questions so far? Now you should be able to find the UC set of the function. Now, we are going to try to use this method to solve for the yp of the following differential equation. And then we do the procedure first, and then I'll conclude it at the end, the method of finding yp by using the UC technique. Yeah. Okay, now we have this differential equation. Is this a homogeneous or non-homogeneous? It is non-homogeneous differential equation. So in that case, the answer y supposed to have two parts, which is yc and yp. So for yc, we find yc first. yc, you've got to write down the characteristic equation. Right? So in this case, it's what? M squared plus 9 equals to 0. Right? We can find two roots of m, which is minus 3i and plus 3i. Case what? 1, 2, 3, or 4. Case 3. yc is equal to the term of the real part is equal to 0. So you would get exponential of 0, which is equal to 1. So we don't need to write down this. So you would get what? The rest of the term, which is what? C1 cos aside first. Cos first. Yes, we can switch. Right? And then the next step is phi yp. When you want to phi yp, the first thing that you've got to consider is just this fx. Like I said, if you want to use UC method, undetermined coefficient method, you got to consider whether this fx is in that four function, polynomial or the power of x, exponential, sine, cos, or the product of that function that I just said. So if you look at this function now, this fx, this UC function, we call it UC function. Is it a UC function? Yes, it is in the case 1. So in that case, we can use this method to phi yp. Okay. Now our fx is x squared. What we have to do is just that we got to find the UC set of this fx. Okay, so we do the first derivative of x squared, the second derivative of x squared. From now we can write down the set, UC set of fx, which is equal to x squared, x, and 1. The next 2, we got no 2, okay? Now, the next step is just that you take a look at the function inside the UC set here. Check it whether it is the same as the function in YC. Is it have any function in UC set of fx the same as the function in YC? If no, we can assume that yp is a linear relationship of this function. I would say a1 x squared plus a2 x plus a3. Because we don't have any x squared in YC, we don't have x in YC, and we don't have 1 in YC. YC you have only cos 3x and sin 3x. It's not the same. So in that case, you can assume that yp is equal to the summation of each function inside the UC set. Now, if we know a1, a2, and a3, we would get yp. Now, next, how to find a1, a2, and a3? They say that if yp is really the answer of this differential equation, then when you put yp in there in the equation, it should be right. It should make this sentence right. So the next step is just that put our yp back into our differential equation. Okay? But now when you look at this differential equation, you see the second derivative of the y, but this one is just yp. So you got to take derivative of this yp 2 times, or we got to find the second derivative of this yp. Okay? The first derivative we would get what? 2a1x. a1, a2, and a3 are constant, just any number that we have to find. Okay? The second derivative of yp equal to 2a1. Okay, and then you just put it back in our differential equation, then we would get 2a1 plus 9a1x squared plus a2x plus a3 equal to 18x squared. And then, because like I said, this one we are going to compare the coefficient of each function. Now we are going to arrange this by take a look at the function. We put x squared and then x and then number. Okay? Right? Now, if you take a look at the function on the left-hand side, you see x squared, you see x, and then you see the constant. On the right-hand side, you have only x squared. But do we have x and do we have the constant? I would say, of course, we have, but it's just in this term. And the next step is just that we are going to compare the coefficient of each function. We take a look at the function of x squared first. If this sentence is correct, then 9a1 is supposed to be equal to 18. And then with the x, 9a2 is supposed to equal to 0. Oh, let me find the number of this one first. So a1 is equal to what? 2. a2 equal to 0. And now the last term, which is 2a1 plus 9a3 equal to 0. Do you know the value of a1? Can you find a3? a3 is equal to what? Minus 4 over 9. Now we know yp is equal, because we said it that yp is equal to a1x squared plus a2x plus a3. Now we know what's a1, what's a2, and what's a3, right? So we got the answer is 2x squared minus 4 over 9. So the answer of this equation is yc plus yp, which is equal to c1 cos 3x plus c2 times sine 3x plus 2x squared minus 4 over 9.